Hello, my name is Cristian Wulkop, and today I'm gonna talk about antibiotics resistance. What if I told you that right now you have 10 times more bacterial cells in your body than human cells? Do not panic yet, this is completely normal. Most bacteria in your body are actually inoffensive or are even beneficial to your health. Some of them help you with digestion, and some of them even help you with your immune system. However, there are some bacteria that can indeed be harmful to your health. The symptoms caused by this type of bacteria range from minor inconveniences to possible death. Thankfully, there are medicines called antibiotics that can help kill or neutralize bacteria that cause the symptoms in your body. However, as of recently, bacteria are becoming more and more resistant to antibiotics. This poses a serious health threat because it might represent the start of some deadly epidemics. I chose this topic because I'm a biochemistry pre-health major and because I'm starting to learn about the processes that cause antibiotics resistance. In this presentation, I'm going to talk about how antibiotics work, why are antibiotics having such a hard time treating bacteria, and what is the scientific world doing to solve this problem. First, I'm going to talk about how antibiotics work so that you can get a clearer picture of the problem. Normally, we do not actually need antibiotics in our body since our immune system should be able to treat bacterial infections. However, when the infections are too large, we take antibiotics to help our immune system. Antibiotics can either be chemically synthesized or they can be found in things like mold. Antibiotics are great because they treat diseases that in the past were deadly and that now are really easily treated by them. But how exactly do they work? According to Nordquist, in an article published by Medical News Today in January 2, 2017, antibiotics neutralize bacteria by either stopping their reproduction or by destroying them. I'm going to show you how exactly this works throughout a video. First, you simply swallow the pill and you wait for it to be dissolved in your stomach. After it's dissolved in your stomach, you have to know that there are two types of antibiotics. There is a bacteriostatic antibiotic, which basically neutralizes bacteria, and there is bactericidal antibiotics that kill bacteria. The first examples that I'm going to show you are of bacteriostatic antibiotics. In the first example, we can see that the antibiotic disrupts the reproduction of DNA from the bacteria so that it cannot further reproduce. Then we have an example of an antibiotic disrupting the enzymatic activity of the bacteria. This kills the bacteria. And also we see some antibiotic disrupting the synthesis of proteins throughout the ribosomes, which also ultimately kill bacteria. In the second antibiotics, this is an example of bactericidal antibiotics. These antibiotics basically go into the cell wall of the bacteria and they basically rip it off, spilling all the contents that the bacteria have and ultimately killing them. Now that we know how antibiotics work, I'm going to talk about why they're having such a hard time in dealing with bacteria. It is a reality that bacteria are becoming increasingly harder to treat, and the reason of this lies in Charles Darwin's natural selection. Individuals undergo random mutations. These mutations can be either beneficial, neutral, or harmful. Some of the beneficial mutations in bacteria give tools for them to fight against antibiotics. If you do not believe me yet, I have a chart here that shows the increase in bacterial resistance. This is a chart that represents the number of gonorrhea cases from 2012 to 2016 in the state of New Hampshire. You can see in 2012 we have only 80 cases, and then in 2016 we have 206 cases. This increase is most likely due to the bacteria that causes gonorrhea becoming increasingly harder to be treated by antibiotics. Bacteria have different defense mechanisms against antibiotics. Some of them protect their cell wall so they are not ripped apart by antibiotics. Some other attack the antibiotics before they even get to them. And finally, others invest energy into pumps so that they can take antibiotics when they get into their body. Ultimately, first, as antibiotics kill non-resistant bacteria, this gives more room and more resources for antibiotic-resistant bacteria to thrive. They reproduce and they have more antibiotics-resistant offspring. Unfortunately, this is not the only way that bacteria have to share their traits. They can also do this. Some bacteria can also do this by, in the moment of death, they release their DNA so that other bacteria can pick them up. Other bacteria connect through their pili, which are basically hair-like appendages, through a process called conjugation, in which they basically share their genes. All of the reasons stated before are contributing to the creation of superbacteria, or more commonly referred as superbugs. Superbugs are bacteria that are resistant to different kinds of antibiotics. And they thrive in antibiotic-rich environments such as hospitals. Now that I've talked about the problem, I know you're all eager to know the solution, but first we need to consider some other problems that might be worth noting. First, antibiotics are freely taken around the world when they actually should be only taken as a last resource drug. By taking them, you basically are killing all of the non-resistant bacteria and giving more resources to the antibiotic-resistant bacteria to thrive, and therefore making it harder on yourself to have treatment in the future. Some foods, like meats, are also treated by antibiotics, and they contribute to the problem in the same way. And finally, there are some things like soap that are also treated with antibiotics that people commonly use without really thinking about the repercussions. However, not everything is bad, since as bacteria evolve, humans do research and they find new antibiotics. However, antibiotics are becoming increasingly hard to develop, so humans are searching new ways to treat bacterial infections. One of them is called phage therapy. Phages are basically viruses for bacteria, so the idea is that we can treat bacteria with phages in the same way that viruses attack us. There's also what is called bacterial infection vaccination, and according to Johems, Weiser, Mali, and Ferreira in an article published in PubMed in December 21st, 2017, there are a lot of functional vaccines to treat bacterial infections, but there are not nearly enough to treat every single strain. As you can see, not every single thing is bad, and also the World Health Organization has prioritized the development of new antibiotics as a first priority. I hope that throughout my presentation you were able to learn more about the subject. I chose the subject because I'm passionate about it and I want to work on it in the future. I also wanted to share it to you so that you know that you can be a part of the solution by using antibiotics responsibly. Not everything that says it has antibiotics on it is good for you. In this presentation, we talked about how antibiotics work, why are antibiotics having such a hard time in dealing with bacteria, and what is the scientific world doing about it. I hope that you learned something, and thank you for your attention.